that might be heard is a real emergency, and that you should leave immediately and leave all of your belongings. And for your comfort, you can find at the back of the room on the paperboard all of the schedule for all the breaks during the day. And in case you want to do your prayers during the day, there is the fast room across this room that will be provided for you. And so now the meeting is in session, and I'm going to welcome Mrs. Nadia Benani, that will be presenting instead of Mr. Hijaji, who is away for an emergency. Thank you very much.
Bonjour à tous et à toutes. La plupart d'entre vous me connaissent, puisqu'il y a beaucoup de nos membres ici, au niveau du cluster Greenage 2. Donc, pour ceux qui ne me connaissent pas, je suis Madame Nadia Benani, coordinatrice au sein du cluster Greenage 2. Donc, comme je viens d'évoquer, je tiens à remercier nos membres présents aujourd'hui pour cette invitation de participation à cette masterclass co-organisée avec Yoko Gawa. I would also like to thank Yoko Gawa for mobilizing experts from far and wide today this masterclass. On behalf of our chairman and CEO, I would like to apologize for not being able to be with us for other commitments. Le cluster Greenage 2, en concertation avec ses membres, il a bien validé un plan d'action à sa dernière assemblée générale basé sur le renforcement de capacités, la promotion, la recherche collaborative et le développement de start-up, et qu'un ensemble d'activités sont en cours de réalisation, et que la plus importante est la conférence internationale sur le e-fuels, pour laquelle on vous invite tous à bloquer sur votre agenda, qui se tiendra le 24 mai au Ferment Salé Rabat. Donc, notez bien ce rendez-vous, ça va être quelque chose vraiment ça va être super important. Voilà, donc on espère que cette masterclass sera bénéfique pour tout le monde, et bien sûr, n'hésitez pas à nous faire part de vos remarques et vos suggestions. Bonne formation à tous. Merci.
So good morning, all. So on behalf of the organizing committee, we extend our appreciation for your presence today. Okay, now you can hear me. So on behalf of the organization committee, we extend our appreciation for your presence today. And let's now start by going through our session program. So, Yokogawa Company introduction by Mr. Yuki Okugawa and Mr. Tariq Hartawi. And then we will cover the portfolio overview by Mr. Fazel Majlisi, the head of the digitalization. And we will shortly after we go over the green hydrogen, global direction and references. And then we will, Mr. Fazel Majlisi will also present the value proposition for green hydrogen ammonia plant as an integrated solution provider. Next, Mr. Sumit Abasan will present the Yokogawa Pexide solution for microgrid control and energy management system in green hydrogen and ammonia plants. Then we will have a short break, coffee break of 50 minutes, and we will continue with our KBC experts and presenting optimization for complete process for green hydrogen, ammonia, ASU, Haberbosch, and digital twin for green hydrogen, ammonia with focus on electrolysis, dynamic modeling and simulation. That will be presented by Dr. Rodolfo Teles-Smith and Ujval Bhatt and Mr. Brian Gogio. Next will be Deepak Sharma, who will present the cyber security. And then the digitalization transformation by digital control of work. After that, we will have a prayer break followed by lunch at shortly after 1 p.m. And we will continue with Mr. Satyana Topa, who will present the special applications relevant to green hydrogen and ammonia analyzer for gas purity and leak detection system DTS based on FO distributed temperature sensor. We will go open forum by Ms. Ayat Kardash, and we will conclude our session with thanks by Mr. Tarek Khattab. So I invite Mr. Yuki Okukawa and Mr. Tarek to go through the company introduction. This one?
Good morning, everyone. I'm Yuki Okukawa from Yokogawa headquarters in Japan. Today, thank you for giving us good opportunities to introduce our activities for hydrogen market. So before starting the main topics, let me introduce our company profile shortly. So we, Yokogawa, established in 19... Okay, can I sequence? But here, okay. So we Yokogawa established in 1915, so it is over 100 years ago, and the founder is Yokogawa Tamisuke. That is his photo, and so our company name is Yokogawa, so that is his family name, Yokogawa. And now we are, we are expanding globally and innovating the market with our product solutions. And for the lower part, you can see this is our DCS. It was released in 1975, so almost 50 years ago. That is our main product, and still it is upgrading and with customers. Also, upper side, that's our business expansion. And the first office was in America, North America, but today I focus on this one. First one is Yokogawa, Middle East and Africa, so we call YMA. So today also YMA members are joining this masterclass event, and they will do the presentation later. Also, this one is KBC. So Yokogawa acquired and also collaborates with a third party to expand our business. So we acquired the KBC, and now we are working together for hydrogen market. So also today KBC will do the presentation remotely, so later. So this slide showed our employees information, and the total is 17,000. And please look at the green color. So that is 11,000, almost 11,000. That is they are working at the outside of Japan. So now we are expanding globally. So that is, you can see this is our global expanding. And today YMA, we call YMA. So YMA
has also over 100 employees. So now we have the strong network in globally. So this is our global network to support the business growth locally. And now this is the headquarters located in Tokyo. And we have the regional headquarters. So that's the America, Korea, China, Russia, Netherlands, Brazil, Singapore, and India, and Bahrain, that's the YMA. Also today, we are here in Morocco. So we have also Yokogawa Morocco office, and today Mr. Tariq will introduce our activities in Morocco later, after my general presentation. So this is our manufacturing facility across the 13 countries. So our main product, DCS, is manufactured in Singapore. Also, our transmitter is manufactured in Kofu, that is in Japan. So we have still developing our manufacturing capability. Also now our YMA also have a manufacturing facility. This is our service support information, and we have over 180 service sites, and plus our service engineers, over 2,500 engineers we have. So if also in addition, we have the regional response center. So if customer has some problem, they can support you and help you. And sometimes it, how to say, matter is very complicated, and then they escalated to the problem to our global response center in Japan. So they will support and solve the problem. So this is my last presentation. So after this, my presentation, Mr. Tariq will present for the Morocco project.
Thank you very much.
Thank you very much. ありがとうございます。
So now the presentation of Moroccan office will be by Mr. Tariq. So over to you.
Thank you, Dean. My name is Tariq Khardawi, and I'm the new country manager for Morocco and the Francophone Africa countries. We are based in Casablanca, and on behalf also of Yokogawa Morocco team, it's a great pleasure to welcome you today. I will just take some few minutes to present our local organization and our local office. Locally, we are based in Casablanca, and we are reporting to our hub, Middle East and Africa. For Middle East, we have more than 5 companies that's covering cross area, including the sales and service units, plus engineering center. Adding that to Africa, in the total, we have 10 companies. We are as total workforce more than 1,400 cross region, with 7 engineering center and 26 sales and service office. Our vision for Morocco and for the local office, Yokogawa has been involved more than 24 years before, but it was indirect business with some channel partner, and the top management was decided to change the strategy and to be direct and contact with the end user directly. And now actually the decision, it was really during the pandemic of COVID in order to support all our customers correctly for the service and the site activities and maintain our install base. Who we serve exactly? We are active in several segments. Chemical, we have solution chemical, oil and gas, petrochemical, water, wastewater, oil and gas, and also for green energy, solar and wind solution. For the scope locally and the team, they have good knowledge, especially for the service activities. The idea that supporting the customer correctly by the local team with some Moroccan faces for all the life cycle agreements, maintenance, preventive, corrective, upgrade, retrofits, commissioning, and the startup. That means all what can be do it. Maybe the engineering can be from external units, but when we switch to project delivery, project execution, all is gonna be locally. Just some figures of the office. That Ikugawa was involved in the local market more than 25 years. Actually, we have also some partners with local qualified company for all the service and the site activities. The setup of the office, it was now since 5 years. That's covering sales activities, service business, and project execution. The local organization, we have seven headcount for Morocco and 2 colleagues for service activities. That's in full time in Congo with the customer Total Energy. This is just a small map showing the main major customer where we are active that having our product and solution, especially for instrumentation and automation solution. If we go to the main and the main player for mining and chemical OCP, we have only in Jorflas far, it's more than 15 units under Ikugawa system, monitored and controlled. Going also to safety side, the main and criteria for production of sulfuric is controlled also by our Santam VP automation solution. Also, if we move on to food and beverage segment for Cozimar, we can tell that the total and all the units and the plants is monitored and controlled by the Ikugawa automation solution. And the only refinery also in Morocco for oil and gas is under Ikugawa DCS that I have chance to start where we start. I think most colleague for us is career. In 2018, we participate to the upgrade, and it was one at this time. It was one of the mega projects in Africa. Finally, and last and not least, for water also segments, the last project with Abengoa as partner, as EPC, we just delivered the project now and is in the handover, is regarding water desalination plants, is the biggest now, I think, in Morocco and all of north of Africa, with a production of 75 million cubic meters per year. And finally, just in conclusion, what I would like to highlight from my presentation that we have the local office, we have the local teams, that we have enough capabilities in order to support all the projects, the developments, not only globally, but also within Morocco. This means that we are in good position to support also new market, new technology, and adding also with a clear strategy for hydrogen and ammonia solution. That was all from my side, just brief introduction to the local team that now we are in Morocco and we have the team and the staff that can support in correctly. Thanks. Thank you all.
Thank you very much, Tarek. And now Mr. Fazal Majlisi will take us over the Ikugawa portfolio. It's over. No, leave that. Where's Lisa? Okay.
Okay, I think everyone can hear me. My name is Fazal Majlisi. I'm the Vice President of Yokogawa Digital Solutions for Middle East and Africa. thank you so much for joining us today in this masterclass. I would like to take you through some of our portfolio very quickly. So you've had all the easy stuff, which is the history lesson. Now we go into a little bit of technical, and I will hand over to the extra technical later on today. So I've got 2 sessions with you today. One is just the overall product portfolio, which I just want to run through very quickly. And then later on, I will give you the session on the integrated solutions and how it relates to green hydrogen and green ammonia. So let's begin. Okay, so overall, overall, what I want to explain to you today is summarized here in one slide. Okay, is in one slide, and it covers the full range of Yokogawa products, from the very simple sensors and instruments that goes towards measuring your parameters and your products, into the analyzer layer, so test and measurement analyzer layer, to be able to analyze the water quality, the parameters that are on the site, and to give you the KPI inputs that you need to be able to do your production. Obviously, the instrumentation system that works both in wired and wireless connectivity in the wireless section. And then we get up to the flow meters and the control system that sits at the top. So we are looking at layer 1 with all the instrumentation, test equipment, analyzers, and then level 2 with a control system consisting of the DCS, distributed control system, the safety system, the SCADA system, and fast tools being the SCADA top end, along with some PLCs. And then on top of that is the specialty software that Yokogawa produces with respect to being able to take the data, manage the data, analyze the data, to be able to form correlations between the different aspects of the production and the data that is being collected, and to be able to satisfy the tagging, the elements of green hydrogen that you need to keep on monitoring with respect to the power, with respect to the production itself, as well as it goes further into generating now solutions using AI, which will allow for more statistical analysis of the data and to be able to correlate solutions from that data, which might not be otherwise visible to the normal control system. So we are in the process of implementing a lot of AI presently in the Middle East, in being able to generate solutions through that AI applications, and to be able to generate solutions where human interaction is being reduced and consistency is being brought into the automation system for that activity. So in effect, this slide covers the full portfolio of Yokogawa that is applicable to green hydrogen and green ammonia, and it is used extensively in those industries. Ammonia, obviously, for the past, 50, 60 years, longer than I've been around, has been used. And the green hydrogen and the hydrogen production is obviously a newer phenomena, but the same set of tools are applicable to both, right? Obviously, our pedigree comes from a very standardized and ruggedized system for the oil and gas sector, which means that the products are extremely durable and they will stand very harsh conditions to be able to operate in deserts and in climates of extreme humidity. So let me take you through very quickly about our vision and how Yokogawa divides up the different sectors of its business. Okay, so Yokogawa has developed a policy of being able to commit to the community and to be able to spread that knowledge and the history of 109 years of greenhouse development, of root development within Japan into the full structure. So we've divided up into 3 main bodies, which is energy and sustainability, And if you look under what is categorized as energy and sustainability, you will find that the market sector we're talking about today is actually under our energy and sustainability activity. We have materials that deals with the high performance chemicals, biomass materials, paper and pulp, and textiles, right? And we have Life business unit that looks after the pharmaceutical, healthcare, food, packaging, right, and all of that. And the product range that I showed you on the slide before actually applies to all of these elements. And what services those is obviously the instrumentation, right? So that, and then the new business sector, which is the ammonia and biotechnology. We go on to the next one. So the direction that we're going in, the marketing terminology, OPREX, deals with the way in which we segregate and we try to develop the products across the whole of our industry. So we have a set of categorizations, operations management. So that looks after the integrated performance and management, automation and standard procedures. We have the production optimization, obviously, which is all the advanced solutions that goes, and the advanced process solutions for that. The plant asset management, which is the facility and the maintenance of it. The supply chain management, to be able to make sure that that supply chain is optimized. And also the sustainable development with respect to the energy management and to make sure that is all optimized. So a lot of the activities is towards making sure that your production is efficient and optimized all the way for your hydrogen and your ammonia development. So OPREX is further divided into the execution phase, which is the transformation, the control, which allows you to control activity, the life cycle, which allows you the long-term support from Yokogawa to be able to maintain the system and to be able to run it. And this is one of the major points that Tarek just mentioned as an operation from our Casablanca office, is the life cycle and the elements associated with that, and obviously the measurement of the system. So I'm just categorizing some of these elements that you saw in the initial pyramid, and how these will react into or be categorized into the different sections. So as you see, the control system is well established, and obviously all of these, and I don't want to count how many of these systems we've got installed globally, but I can tell you that it's over 1,000, well over 1,000 systems that are operational in the field. And obviously the measurement systems, including both wired, wireless, and our newer sensors, sushi sensors, which are completely wireless, and it will operate on a battery and be able to measure the vibration, temperature, and pressure across it for quick deployment. And obviously, we've got the chart recorders to allow for quick deployment within existing establishment when there is no control system, and the diode lasers spectrum to be able to measure the impurities and also the gas analyzers. So this is the section that I really want to emphasize to you. Obviously, all the control systems and the control elements that measure and control is predominantly available and everyone knows about it. What really distinguishes Yokogawa is all the solutions that sits at the layer 3 and the layer 4 to be able to generate all the optimization and all the energy management that you require to be able to generate your hydrogen and ammonia in the most efficient way, right? And it is the integration of these solutions, as you see, as we've listed them, along with the control system, a stable control system, and a reliable measurement system that allows for an efficient operation, right? And therefore, all of these elements are integrated together to be able to provide the most cost-effective and reduce the total cost of ownership. I'll get to this part in my next presentation. So we look at the measurement systems, the scopes, the single loop analyzers, the handheld devices, and so on. And we have obviously all of the other elements with respect to IoTs, IoTs, and the development further on. Right? So that's all the measurement equipment. Now, all of that, as I mentioned, is to move you from level 1, which is the basic measurement, all the way into the control system, into the production management, which is doing all your daily production targeting and production monitoring, into a demilitarized zone, and then into the business layer for the board members to be able to see the dashboards and the production and the reports on a live and daily basis, so that the complete system is integrated all the way up. Okay? And we've listed some of the elements on the sides that relate to each one of the levels, right? And how these work again as an integrated element to be able to do that system. Okay. So I've got to the end of my presentation. This is the last slide. So I just do a quick recap before I let the next person along. So Yokogawa, through its instrumentation, sitting at the bottom layer, the control system, the management system, and the advanced solutions, provide an integrated element to be able to control the plants. And obviously, the solutions are well versed across globally at different market sectors, including a lot of ammonia production that we're involved with in the Middle East, and also now getting into the green hydrogen and the green ammonia as we move forward. So we will go into more details along with the integrated and why it needs to be integrated in my next presentation. And we will go into some of the advanced solutions which are required for your operations. Thank you very much.
Very much, Mr. Fazel, for your great presentation of Yokogawa portfolio. Now, I would invite Mr. Yuki. Yes.
Okay. There we go. Okay. Okay. Good morning. Morning. So once again, thank you very much for joining this masterclass session. So I'm Furuya Yuki from. Okay. Apologize. I'm Furuya Yuki from Yokogawa Electric Corporation, headquarters stationed in Tokyo, Japan, with Okukawa-san, who made a presentation about the company introduction. So during my session, so I'd like to introduce green hydrogen, global direction, and also current reference and some activities. So for this session, we would like you to be aware of our reference in hydrogen, including green hydrogen, green ammonia, and you can be also aware that we would have the potential capability, not only conventional I&C sector, but also the further contribution such as optimization, efficiency, etc. So please enjoy my session. Okay, so this slide shows our key message for entire hydrogen market. All right, so connect all in scaling hydrogen value chain. Now, hydrogen is, I can say, we can say at the beginning, but it would be very important energy source in the near future. And this point shows the future entire hydrogen value chain across the portfolio, across the industry, etc., across the maybe region, countries, etc. Now, Yokogawa has been working for various industries such as oil and gas, chemical, fertilizer, power, water, etc. And most of the plants have a really, we can say, relatively centralized facilities. But in case of hydrogen, in particular green hydrogen, we assume that it would be more like decentralized energy supply chain rather than centralized one. That's why we think, yes, it is very important to focus on each factor, such as power plant or renewable power plant or hydrogen production plant or demand center. But not only that, we aim to contribute to connect value chain so that we can give the kind of benefit for the multiple stakeholders along with the hydrogen supply chain. So one of our Yokogawa's concept is system of systems to connect across the value chain, different stakeholders, different shareholders, etc. So we would like to keep our effort to somehow contribute to this upcoming hydrogen value chain. This is our message as of today. Okay. Apologize. This slide looks very busy. So as our father introduced, we have a complete range of portfolio which can be utilized for hydrogen platform. So this slide shows the sensing technology and control and further layer 3 and 3. And this one shows the hydrogen production, conversion, freight transportation up to utilization. Then across the section and also supply chain, we have some confidence that we can contribute to any full range of the solution. And this green color means that we already have a field of probable difference in any of hydrogen project or plant. And blue color one is still we need to look at the reference. However, we have a confidence that those solutions can be beneficial for the hydrogen value chain. And the rest of that we will consider for future roadmap. But we'd like to say that Yokogawa can cover entire solution to be applicable for the green hydrogen, green ammonia, etc. Okay. So this is just example. So this is about Yokogawa Cloud Platform, which is really recently introduced to the market. Okay. So we have a cloud solution can make our customer to start to use the AI technology for the data analysis or data integration as of today. Yeah, you don't have to wait for that. So this Yokogawa Cloud Platform should be one of the key solutions for the decentralized hydrogen supply chain. Yes. So we have recently introduced, but it can be utilized from today, if you wish. And today, so our professionals from KBC will introduce the detail. But not only the control and sensing layer, we understand that some optimization or kind of simulation so that our shareholders can study how to efficiently operate the hydrogen production plant, etc. So we have a solution for the simulation technique and also some about energy management to efficiently operate your plant. So we already have a concept. And also in the field side, we have many sensing technologies or controllers, such as flow meters, pressure transmitters, or IIoT sensors. And also we also have the in-house AI developed by Yokogawa, which can contribute to any industries, including green hydrogen production. Yeah, this slide shows the electrolysis package. Okay. And now, so I'd like to switch to the project reference from the solution. This slide shows our hydrogen selected reference in the world. You can see this green color means green hydrogen production related. Blue, yes, blue hydrogen related. And the rest of them without color integrate some demand reference in the demand center or hydrogen conversion, such as a hydrogen liquefaction plant or hydrogen refilling station, etc. So we already have some field proven reference in the instrumental control layer for the green hydrogen, blue hydrogen, etc. And some of the projects are really national important project in Netherlands, Australia, or even United States, etc. So we have been already working on those projects. And in addition, not only green hydrogen, we need to look at green ammonia as well. We already have over 400 plus DCS control system reference for ammonia urea plant. Yes, actually, this is almost, we can say, gray ammonia with a Haber-Bosch method, but we are ready for the contribution of the green ammonia technology with a combination of the green hydrogen or blue hydrogen production. Okay, so out of our ample reference, I'd like to highlight two projects in Netherlands and Australia. Those are the, how can I say, nearly remarkable reference, which we have shown systems integration technique to integrate different package into our system so that our stakeholder can visualize the plant status with efficiency. Yes, these are different slides. First one is Holland Hydrogen 1, developed by Shell in Netherlands. The location is Port of Rotterdam, which is one of the energy sector in Europe, located in Netherlands. Another one is Australia, Uri Green Hydrogen Project. This is also a green hydrogen project to provide green hydrogen to existing fertilizer plant to make fertilizer green from gray, like that. And in addition to that, we are also involved in some commercial project as well as demonstration project. In Japan, government and also our stakeholders have been working on the demonstration project in hydrogen sector last around more than 10 years. Like Japan FH2R, this is one of the biggest green hydrogen plant located in Japan, Fukushima Prefecture, with 10 megawatt alkaline electrolyzer. We have provided our DCS for the electrolyzer control, and also we have been involved in some demonstration projects to optimize hydrogen distribution to the stakeholders. And also this AHEAD project and ACE Energy Supply Chain Pilot, those are the projects to establish hydrogen trading with some energy carrier with the technique of the organic ranking cycle, what we call MCH, or liquefied hydrogen developed by Chiyoda, also Kawasaki, like that. And in addition to that, in Europe, there are some pilot projects to demonstrate electrolyzer plant in France and Denmark, etc. Our solution have been somehow utilized. And also, not only those INC projects, but also we are also working on another demonstration project, POC, to give additional contribution in UK and also Netherlands to somehow optimize your production plant, somehow scale up the hydrogen production with efficient operation, etc. And also, our product is utilized for different station and liquefaction plant, etc. Okay. This slide shows the Shell Holland Hydrogen 1 project. This is a computer graphics. Actually, it is still under construction, but we are selected as a main automation contractor to supply the system of systems configured kind of monitoring and visualization system, etc. And this slide shows the Uri Green Hydrogen project in Australia. So for this, there is I can say ammonia plant, a fertilizer plant, which started the operation in around 2010 or something like that. And for this, to make it more green, this Uri operation developed by NG and Mitsui started to build green hydrogen plant beside this plant to provide green hydrogen to the this fertilizer plant. So we will provide the same centralized control system and energy management system to make this variable renewable energy mix stable with a very high speed and microgrid control, which will be introduced later by our colleague. And actually, this project have a roadmap up to around 2030. We are involved in from the phase 0 project. Actually, the hydrogen production will be relatively small concerning the entire demand of the hydrogen, but that will be increased to make it really green in the future. Why we are selected? Because our system would be really flexible for the expanding supply chain and also process volume, etc. That's why our system will be deployed so that we can be somehow adaptive for the expanding capacity with flexibility. Now, I'd like to briefly introduce one of our activity with a demonstration. This is one of the demonstration project we are involved in UK. The project name is High Bond Project. Okay, so what we will demonstrate is energy management system for the green hydrogen production plant. For optimized green hydrogen production schedule to minimize hydrogen production cost. So the resource will be variable renewable energy such as solar PV, wind power, as well as grid power. That combination. Then without EMS, hydrogen production will be conducted by just a local controller. Then hydrogen is consumed, then hydrogen is produced. But ideally, hydrogen production will need to look at the condition of the forecasting of renewable energy, price, hydrogen demand, and also storage control, storage management of the hydrogen tank, etc. That should be considered for the more efficient hydrogen production schedule. So we are trying to demonstrate if our ready-made solution can contribute to that one. So that is a kind of challenge. And this project, we are working with Marubeni, one of the very big business company in Japan. So this project has been also nominated in the UK hydrogen allocation round. You can say this is kind of subsidy program for the green hydrogen project developer. So last December, it was announced that 11 projects was nominated. Project is one of them. So what I want to say is we are really involved in not only the commercial project, but also this kind of challenging project we are involved, so that we can expand our contribution to the customer. This is the last slide. So even if we are successful in the demonstration project, if it is really full customized, it could be difficult to introduce the customer. So we are trying to utilize our platform so that we can somehow standardize it as possible, so that we can accelerate to introduce other shareholders for the scaling up green hydrogen society. Okay, thank you very much for your attention. So this is the end of presentation. So please enjoy the rest of sessions. Thank you very much.
Thank you very much, Reza-san.
Yes.
H. Okay. So, Mr. Fazal, you will tell us more about the value proposition, Yokogawa value proposition for green hydrogen ammonia plant as an integrated solution provider. After you, Fazal.
Okay, once again, I hope everyone can hear me across to the end. And the mic is working? Okay, thank you so much. So I'm going to tell you a little bit about why an integrated solution is required for your hydrogen production and how the process demands such an integrated facility and integrated solution to be able to reduce the total cost of ownership. The total cost of ownership is the addition of the capex that is being expended on the development and the operational cost of the running the plant. And as at Yokogawa, we are interested in the total cost of operation rather than each aspect separately. So some of the activities I will show you as we go along with that. So value. Not picking up. Okay. All right. Thank you. So the value-added solutions for the plant sections. So this is a very simplified green hydrogen, green ammonia outline. And obviously the most critical element that is generating the hydrogen is the electrolysis process that is generating the actual feed, either going into your nitrogen production or as hydrogen itself being exported to various elements or buyers or end users going along. Obviously, the green part of it, or why the green tagging comes along, and that green tagging is critical for our discussions today, comes all from the power generation that goes into the electrolysis and the air separation units as being the most critical two elements. So the power generation is based on renewable power, right? So that can be solar, wind, right? And the power generation will feed both the electrolysis and the nitrogen and the air separation unit, generating the hydrogen either to go into the ammonia production or being exported. As part of the power generation or the renewable, we have the battery system that is the energy backup to be able to sustain a steady power supply while there is disturbances in the renewable energy supply. So this is extremely critical to your electrolysis process, and it means that we need to have consistency along with those electrolysis. The electrolysis process itself will degrade significantly if there is any disruption to that power, and therefore the battery system that is used is predominantly keeping that electrolysis process running at its optimal manner. One point to remember is that this battery system is not to maintain operations during the dark hours or maintain operations when there is no renewable energy. It is only to smooth out the variables or the inconsistency of getting a cloud coverage, maybe for the solar, or getting wind disturbances on the turbines as we move forward. Okay, but it is a critical element in your electrolysis process. Now, obviously, the renewable energy is matched along with some form of power to be able taken from the grid to be able to sustain that in case of that, or there could be some diesel generators or gas generators, which will gas turbines and diesel turbines, which will allow for some production to go on alongside it. But obviously, the energy management system will have to take that into account and to be able to sustain that and give you that green tag that is required for the overall operation. So once the hydrogen is generated, we either get it into ammonia form and be able to export that globally or use it locally, or we leave it in the hydrogen form and be able to send it to the various users in its hydrogen form. I believe that a lot of our activities here in Morocco is routing that hydrogen into the ammonia production using the air separation to give us the nitrogen that we need. And obviously in its ammonia form, once it's exported, we have the association, the section that brings back the H2. Now, it is pretty obvious that one of the major elements for these units, both the electrolysis and the aspiration unit, the nitrogen, is the water supply. And as part of that water supply, you will require some form of a desalination, maybe some water purification mechanism, either by reverse osmosis, right, or by some other mechanism to be able to do it, to get that water into the system. So there is a lot of interactions. It is not just the electrolysis process that results in the hydrogen, but there is also the power generation and the power management to be able to have the clean water, filtered water that is required depending on the technology of electrolysis that you're using, because the grade of pure water is different between different manufacturers of electrolysis units, and obviously the air separation unit requires the same. So that part of the system will also require a control system to be able to do its work. So the least amount of integrated control system that is required is actually the electrolysis unit itself, right? Because that is purchased from a license holder, from a patented company, which will come along and put that in. But it is all the added process units with regards to the water processing, with regards to the filtration and the power management that is making that requirement for integrated control system and all the software that goes on top. So if I go further and simplify the elements that go into that operation, so we have the upstream power, where the power is from solar, wind, we've got the battery, we've got the power and flow management. Now, sometimes the power is remote, and we would require that the power generation, so the wind farm or the solar farm, could be a distance away from the ammonia production or from the hydrogen electrolysis production, and therefore we would require a transmission management, right, and the contingency management, and overall we would require a EMS system with respect to the mini grid that you have set up in being able to generate your power. So what I mean by mini grid is this grid here, not the main grid bringing the power in. But you would need an energy management system to be able to manage that grid and to be able to make sure that it's optimized. So that all goes into that element. Then we've got the green hydrogen. Now, electrolysis systems work in various mechanisms, right? So I don't want to get too far into that element of it. And obviously, it comes in as a package from an OEM or from a license holder. And we would obviously need auxiliary systems that support that green hydrogen electrolysis and the compressor and the storage to be able to hold the hydrogen, because a storage mechanism for the hydrogen is required by itself to allow for the peaks and troughs of the offtake of that hydrogen, both for ammonia and for the export line. And then we've got the green ammonia itself. So we've got the separation unit, we've got the ammonia synthesis, ammonia storage, and the ammonia export. So all of that requires an integrated control to be able to do. And then the balance of plant, which is the water, either by seawater reverse osmosis or the seawater, and then the polisher to be able to form the water into a standard that is required by the electrolysis system, either filtration or some sort of water purification step to get it into the right quality for that. And obviously some electrolysis systems are more sensitive to that water quality, some of them are less sensitive to that water quality. Right, and then we've got the general auxiliaries that require. So overall, the complete process can be divided up into these 4 sections, right? A lot of complexity goes into each section, but that is the main elements going in. So let's go through the main set of problems that you might see when you come to generate your system. So we have obviously the first element, which is the power. And you will see that there is variations in the power generation from renewables. You will see that there is grid stability required to be able to do that. The quality of power, that is very important to your operations and it needs to be controlled. Ensure net green. So what are you using from the grid? What are you using from diesel generators or gas generators, right? Against what is being produced by solar. Now, obviously, if you have a mechanism where you're generating enough solar or renewable energy to be able to sell back to the grid, right, and buy from the grid where the demand, where the solar or renewable is not available, then the whole complexity of how the energy management system is done becomes a lot more difficult and it becomes a lot more complex. Because now you need to have a billing system for where you're selling energy to the grid and a offset of when you take energy off the grid. Okay, so all of these are concerns that you need to have. Obviously, the battery backup mechanism to make sure that you have the correct stability, right? Variable demands of electricity prediction, right? To be able to predict how much power you're going to be generating from the solar, from the weather conditions, and to be able to bring online additional power, green power, to be able to maintain your production levels. And the transmission management and contingency management for the network, and the variability management of the isolated or synchronized power. So all of these constraints are elements that you need to think about when you come to generate that power unit by itself to give you the green tag that is required to designate yourself as green hydrogen or green ammonia. And what we have is the energy management system for RE, for renewable energy, that takes control of all of these elements and is able to maintain all of this. So this will be discussed further in our later slides and later activities to be able to give you a little bit more. So your problems are here, right, listed out, only some of them, there is more. And here is a solution that is recommended for it, which is the energy management system. So that energy managed system is, obviously the details will be given to you in later slides. I don't want to get too far into it. I just want you to be familiar with the terminology. That is made up of our CI server from Yokogawa and PICE from our sister company, that is a Yokogawa company that develops this product by itself, and it generates all of the elements that you require to be able to maintain, monitor, and report on the energy usage of the systems. So as I said, I don't want to get too far into it. There is a complete session on this, and I'll leave it to the other guys to be able to show that. Then we move on to the next element. So the next element of problems that you will see is obviously the green hydrogen production itself, right? And obviously you would need instrumentation, which is accurate instrumentation, highly reliable. You would need analyzers, right, to be able to analyze the flow meters and to be able to accurately measure the flow of elements, and voltage capacity for storage of the voltage, and the gas purity and density analyzers to move it along. You will need all of these instrumentation to feed into an integrated control platform, and the compressor control and optimization of the control system for the electrolysis as embedded. And then you will need the safety system to be able to bring that elements into the safety world and make sure that everyone is operating. So overall, this part is pretty straightforward for Yokogawa, and it is our embedded instrumentation control system that I showed you earlier on today. at the various levels moving up the pyramid. So overall is the analyzers, the control system, DCS, and the model-based control and digital twins. So again, this we will get into the APC and the digital twin later on during the day. I just want you to be able to see where it fits in the overall picture. So one very critical element that people always ask us about why Yokogawa has got into the green hydrogen and green ammonia business. You see, the part that is doing the hydrogen production, which is the electrolysis, right, that is going on, that forms a very small percentage of the overall complexity of the plant that takes the water in, it produces the separation, it feeds into the electrolysis and then manages to be able to be filtered and do all the other work, both for LA electrolysis and PIM electrolysis, okay? So all of that element of electrolysis forms a very small portion of the overall challenge of being able to produce green energy, right? And green hydrogen and green ammonia. So this is where we require that integration of the system and to be able to provide this total solution from the instrumentation to the control system, to the advanced solutions, to the energy management system, to the APC, and hopefully we will find some application for artificial intelligence here. Okay, so this is to address that. And obviously some of our companies, there's a company called KBC, you will have a presentation later on in the session with regards to our simulation, right, of the electrolysis and the systems itself. So we have modeled, right, both statistical and dynamic models are coming out of that electrolysis processes using our product called PetroSim. That PetroSim session will come along, but we are working towards the analysis of that and the modeling, which means that now, based on that model, you could have a operator training system, right, that mimics the live plant, and that operator training system can be used to quickly develop your operators on a new process and bring them online quickly and get the production consistent, right? It also helps with the overall design of the dynamics of the plant, right, to have this. So the green ammonia itself, again, obviously you need the reliable control system, the instrumentation, the modeling, simulation and optimization of it, right, to be able to work. And obviously we've done a lot of work, as my colleagues mentioned earlier on, with respect to our APC algorithms that was co-developed by Shell and ourselves, and has been rolling out to a lot of the installed base, and the modeling, simulation, optimization, and the integrated compressor control. So all of that elements for the green ammonia is listed on the side, and it is available with Yokogawa already, which is the field instrument analyzers, DCS, embedded compressor control, the APC, process digital twins, operator training simulators, as I mentioned, and the EX. All right. Now, so all of the products are available, and we have been involved with ammonia production, I think from day one of ammonia production, okay, which is the last 50 or 60 years globally. Now, obviously, what makes it green is the energy that goes into that ammonia production and gives it to us. But overall, the ammonia production unit itself is the same as elsewhere. So one of our APC and optimization, obviously the session will be for that element. And the APC and optimization is critical to bring down the cost of ownership, right? We cannot have a plant running or a ammonia and hydrogen production where the parameters are not tightly controlled and that the KPIs are not clearly defined. So the APC and the optimization is a critical factor that goes into the overall cost